Thank you. Yeah, my name is Irit Katriel. I work at Microsoft. I'm a Python core developer. And I'm here to talk about some new features that will be in Python 3.11, which is going to be released next month. So we're having our release candidate already that you can test. Please do test. But the official release will be next month. And these features they allow you to raise and handle multiple unrelated exceptions. Let me first explain what that means. So when I say raise exception, I mean use the raise keyword to raise an exception object. It has a type, it has a message. If you don't catch it, your program will terminate with the type and message and a traceback that shows you where in your program execution stopped. And handling exceptions is when you wrap a block of code with a try except, and instead of letting that exception to propagate all the way up, you catch it and you intercept it and say, I can recover, right? I have some recovery code to run, so do something failed, so we try to do something else. Now, in a situation like this, when you raise and catch and raise another exception, we have a program that raised multiple exceptions, but these exceptions are related because they happen in the same calculation. The second couldn't have happened if it wasn't for the first. And so these are related exceptions. We used to have a problem with related exceptions in Python 2. The first exception would be lost. You would get only the second exception in your traceback. In Python 3, from 3.0, we got exception chaining. And now the first exception is attached to the second exception through the dunder context field, and you can chain as many exceptions as you want, and you don't lose information when this happens. So that we don't have a problem anymore with related exceptions. Unrelated exceptions is when we have something like this. This is a simplified version of a function from the Python standard library, which creates a socket connection. So you give it a host and a port. It calls a function that gives all the configuration that the local host supports. So, which network protocol, which socket type. And then the function iterates over all of them, tries to make a connection depending on what's going on the other machine. Hopefully one of the configurations will work, we make a connection and we return it. If they all fail, then now we need to report failure. What we do in Python 3.10 is we just raise the last exception. We forget all the previous exceptions, raise the last one. You don't know how many attempts were made, you don't know why they failed, you only know why the last one failed. In Python 3.11, we have the ability to raise all these exceptions together in a group, and this function knows how to do that. There's a new parameter, you need to opt into it because it's an API breaking change, but you can get all the errors of all the attempts that happen. Another example of unrelated exceptions comes from the asyncio library. We have a function called asyncio gather. You give it a bunch of async awaitables. It awaits all of them and returns the results in a list. But what if one or more of them raise exceptions? So you have two options. You can say you have this return exceptions parameter, and one option is to say, give me the first exception, forget about anything else that happened. So once again, we lose information about other things that are going on. Or the other alternative is, give me the exceptions in the list of results. So instead of a result, give me an exception, and then you can iterate over the exceptions, over the results, and ask, is any of them an exception? What is the type of this exception? You can't handle it with try except, like you handle exceptions in Python. So neither of these options is very good, and in Python 3.11, we have we didn't do the same thing as with the socket module. Rather than adding an option for this function to raise a group, there is a new API that is replacing it. It's called task groups. It improves on asyncio gather in a number of ways, other than raising exceptions. This is why the asyncio maintainers opted to create an entirely new API and just say, stop using gather, this is better. I won't talk about it because I want to talk about exception groups and how they work and the design choices we made when we implemented them. I don't want to talk about use cases, but Lucas Lange gave a talk earlier this year. It's on YouTube. He covers it very well, so I'll refer you to his talk. So what is it that we added in 3.11? We added two things. There is an exception group type. It's an exception that can wrap other exceptions. There's nothing earth-shatteringly new about this. You've probably seen it before. Many libraries implemented something like this. But the new thing that this is something you haven't seen before is the except star syntax, which is except for groups. It's a generalization of except, but for groups. And the gist of it is that if you wrap a block of code with try except star, then each clause of the except star will capture all of the exceptions in the group that match the type of that clause. Now we'll see a bit in more detail how this works. So this exception group wrapper, as I said, nothing new here, but it wraps a list of exceptions, but even here we had a few design decisions to make. So an exception group can be nested. We said an exception group is an exception, so it can be in the list of exceptions. You get a tree. I want you to get used to this diagram because you won't see code like here anymore, or not a lot. The rest of the slides will have these diagrams. So the group is a tree. These blue rectangles are exception groups, and the leaves are various types. It doesn't even matter which types. We'll just call them green triangle and so on. And the numbers on them are instance IDs. So the 2 and 4 are both of the same type, but they are different instances. Okay? Now, this tree structure is shown in the traceback output. You'll be pleased to know. We use indentation to show the whole tree. So, so the first design question is why nested? Why didn't we just take the list of lists and flatten it to a list? It would be much simpler, just a list of exceptions. So the reason is that this tree structure is meaningful. This is what happened in your program. Exception 3 and exception 4 were caught, and they got merged into the task, by task 2, they were merged into an exception group that was raised. It was caught. Exception 1 and exception 2 were caught as well, grouped with that and raised. You can see that from that structure. So that tells you a lot about what happened in your program. In addition to that, every exception has some metadata on it. There are these cause, the chaining fields, the cause and context, and then there's the traceback of the exception. Exception groups have that too. If we get rid of the intermediate task 2 node, where do we put that metadata? So we did think this through, and the option of flattening into a list was considered, but we decided for these reasons not to do that. Now, the most important operation on exception groups, and we'll see this quite a lot later, is split. It actually has this function that you can call. You give it a type, and it splits your group into the matching part and the non-matching part. And you can see that the intermediate exception group nodes, where you need to duplicate it, they get duplicated, they get copied. All the metadata gets copied. These are shallow copies. But from the point of view of every leaf, if you look to the root, you see the same thing. So now, before I go to except star, let's talk about try except. Let's assume we have a very complicated try except construct like here. So we can catch the orange hexagon, and if we do, we swallow it, and we raise a yellow diamond instead. If we catch a purple plus sign, then we just re-raise it. It's as if we never caught it. Just re-raise it. If we catch a green triangle, we swallow it, because we don't do anything, right? And if anything else is raised, then it's not caught, so it just propagates on. So this is a complicated construct. A lot can happen here, but we can know that whatever happen, at most one exception will be thrown from the try block. It's either handled or not. It's all or nothing. We know that at most one of the except clauses will execute, and at most one exception is thrown at the end. None of this holds when we go to except star. So let's walk through except star and see how it works. So we have a try block, we raise this exception group. So the first except star green triangle splits on green triangle. Yeah? The matching part gets bound to the variable e, and we execute this clause. Now the next except star clause sees the remainder. So the green triangles are not considered for matching anymore. They have been consumed. We look at the remainder, and there is a purple plus that is matched, and then we have the remaining group with the orange hexagon that gets propagated on, because we didn't handle it. So now, this has some similarities with except. Just like except, we know that each exception is handled by exactly at most one clause, and each clause executes at most once. You execute the clause once on the whole group. But unlike except, we see that multiple clauses can be executed, and we can have partial matching of the exception. So these are differences. Now, the biggest question when we discuss the spec, or when we discuss the design, is, do we really need to add new syntax to the language? To add a built-in exception group, that was easy to sell. To add new syntax to the language, the bar is much higher for that. And so let me try to convince you that we made the right decision, that we really needed to do that. So let's assume we don't. Let's assume we use try except, we catch the exception group because it's an exception, we can catch it. We call split on it. We do what we want to do with the matching part, whatever was in this except star clause, and then we raise the rest. So first of all, you better not forget to raise the rest. So yeah, but we know how to do this. You write a context manager, and the context manager raises the rest for you. And if you want to handle, you have more than one except star clause, maybe you nest them or something, I don't know. Now, we could do this. People have done this. There are a number of libraries that implement things like this. Nobody likes it. This isn't how you want to program. And it's not something that we would have included in the Python language, in the standard library of Python. But maybe we can teach except to work with groups. Groups are new, right? It's a completely new type. Anything we do is going to be backwards compatible because there's no history. So let's just change the way except work with groups. So there are two ways you could think of doing that. The first way, you could say that except T as E means that from now on, E can be either a T or a group of T's, right? And the second option is to say that E is always a T, but you execute this clause once for each exception of type T in the group. So you iterate over the leaf exceptions of this type and execute this clause multiple times, potentially. Now, neither of these is backwards compatible. Not because of what they do to exception groups, but because the way that old code would interact with exception groups. So imagine you have code like this. For the first option, we have code that handles OS errors, right? And in the clause, it can assume that E is of type OS error, and OS error has an error number field, so it can access that field. Now one day, E is an exception group of OS errors. Exception group doesn't have that error number field. So that code will fail with an attribute error. This is legal code that exists now in libraries. The other exception, the other case is for option 2 is something like, okay, you open the file, you have a try except, you go to the exception handler, you write something to the file and close it. This is legal now. We know that the except clause will only execute once. But if we start iterating over the exceptions in the group and executing it more than once, then suddenly this legal code breaks because the second time it executes, it's writing to a closed file. So now that I convinced you that we need the new syntax, let's look at a point that I left out before, like what happens when we raise exceptions from except star clauses. Let's look at this code. Well, there's a new type here, red star. It doesn't matter what it is, it's just a type. We raise this group, and we have code that is kind of like the example we saw before with except, but it's except star. So now, we need to raise the yellow diamond from the except star orange hexagon clause, and we need to re-raise the exception group of the purple plus sign that we caught, and we swallow the blue triangle, and then there's an unhandled part that we need to raise as well. So, well, we know what to do when we have a bunch of exceptions that we want to raise. We group them and raise a group. There is a subtlety here that because the purple and red came from the original group, we want to merge them back into the same structure that they had in the original exception group. So we first merge them together. And it's as if we just split them out from the original group. And then we take them plus all the new exceptions that were raised in the except star clauses, and we merge them, and this is what gets raised in the end. You can see that we added a level of depth to this tree. But this makes sense because what this piece of code does implicitly is to take groups and merge them together. That's what it says. Now, with that, is except star syntactic sugar? Okay, it's very ugly to write code without it, but let's assume we don't care about how ugly the code is. Can it be implemented in terms of Python? Just the other parts of Python. So this is an example of showing that finally is syntactic sugar. The code on the right, it's longer. It has C repeated twice. You don't want to write code like that, but it is equivalent to what's written on the left. And that is actually what the Python compiler does. There is no finally bytecode. There's nothing in the interpreter that does finally. It just duplicates the code. So could we do this with except star? Could we rewrite a try except star clause in terms of except? So the answer is I believe that we can't, because the part where it breaks is where you re-raise the rest. So if you raise an exception explicitly, you add a frame to the traceback. And you can fix tracebacks before you raise the exceptions, but there's no opportunity here to fix the traceback. So if we try to rewrite accept stars in terms of accept, it will kind of work, but the tracebacks will be polluted with kind of framework frames. So in that sense, we can't quite get accept star in terms of existing Python language, and we do have new opcodes that implement accept star and splitting, merging, all that. So to summarize, we have features in Python 3.11 coming next month that let you raise and handle groups of unrelated exceptions. The motivation was asyncio task groups, but we also have non-async use cases. There's a bit of a misconception that exception groups are an asyncio feature. They're not. They were motivated by asyncio features, but they are applicable more broadly. And I know from a member of the steering council that this was important for them when they accepted this feature, that it's not just for some edge case in asyncio. Accept star is a new syntax to generalize except for groups. More details in the PEP, in the documentation, in the code. Please do read the documentation. I didn't cover everything. Thank you.